Hello and welcome back. So this should be pretty much our last video in this little sub-series about creating your own parser by hand. And what Nelson's going to do is provide just a bit of a recap now that we've got all of the code in place and everything's functioning, all of our tests are passing. He's just going to go ahead and walk back through what's going on. Again, this video is really targeted towards those that have been following along with the video series and perhaps their coding skills weren't all the way up to chops or just weren't quite to this level of coding yet, and a review would be helpful. So with that, Nelson, let me go ahead and turn it over to you, and let's see what you can come up with.
So yeah, we built a parser and we wrote it by hand. And the goal of the parser was to, if you think about the goal of the parser in its just in simplest form, it was to translate structured text like this that conforms to a particular language and translate that into invocations of methods on these interfaces.
Mm-hmm.
So we have the style sheet builder, which creates rules. We have the rule builder, which creates selectors and sets properties, and the selector builder, which assembles a selector. Now that the parser is able to understand this language, what it can do is it can invoke these methods in the correct order, so that we can do whatever we need to by providing a set of these a set of classes that implement these interfaces. We can do anything from assembling a style sheet in memory to maybe dumping the entire style sheet into some sort of binary format that doesn't require any parsing, that we can just load up whenever we need it.
Right.
So the functionality, so takes this text, turns it into method calls. The lowest level or the highest level, that's what it does.
Okay.
Now, at a slightly lower level, what it needs to do is go through a few different steps. And the first step is always going to be lexing. And lexing identifies common words within a piece of text, or types of words, specifically called tokens. So you see that with our lexer test, we instruct our lexer to go ahead and take in this structured text and turn it into a stream of all of these tokens. And what we can do with these tokens is very easily match them against what tokens we expect and so on. It makes parsing a lot easier when all we have to worry about is tokens and not how to identify particular tokens.
Okay.
Yeah. Okay, so the next step is we have our parser, which sits on top of our lexer. The lexer will feed the parser a bunch of these tokens, so it'll feed it a dot and an identifier and an open curly, and I just screwed up that test. And the parser will then take all of that information and walk through it. You can think about it just walking through it. It finds some token, and then it establishes a possible meaning for that token, and then it continues to parse that possible meaning until the end of that meaning. So, for example, it would see this dot. It would say, okay, we are in a class selector. It'll continue to parse through this text and find out that we have an identifier, which it expects, and then it'll return back to the initial structure, which will, of course, identify this open curly and begin parsing the rule. So what that looks like, it's pretty straightforward. We have a main method called parse, which simply runs through the entire stream of tokens. And for every one of those, it invokes the method called rule. Rule jumps down, and it starts. This is the first time that you'll see us invoking methods on those interfaces. Then the rule says, okay, parse all the selectors, eat up an O curly, and then parse all the properties. Then eat up a close curly. Selectors is just another level deep in specificness, where we go ahead and create a selector builder, the second invocation of our interfaces, and we just simply loop through all of our tokens until we find a no curly. And while we're inside of that loop, we first parse out a selector type, then we identify if it has a relationship with another type of selector, and then we just repeat the loop. So this is what's called a recursive descent parser, because it descends into very, very specific, really readable pieces of code. Because once you jump down to selectors, we do a basic look-ahead check. Are we looking at a dot, a hash, an ident, or a colon? Depending on the result of that check, we will go even deeper. So for example, a class selector will match, eat up the dot, pull out the class text, eat up the identifier, and then invoke a method on our interfaces. The same pattern you can see with the class selector, the ID selector, the element selector, and the pseudo selector. Now, properties are a little bit interesting because the property values, or what can go into a property, is polymorphic, meaning that a property can contain 0 to many values, and those values can be of any type. So what we have to do is first match out the name of the property by taking it out of the look-ahead, eating up an identifier, then eating up a colon, and then looping through the rest of the tokens until we find a semicolon, which you'll see down in this while condition where look-ahead type is not a semicolon, and then we will parse out the individual properties. And again, this is just the exact same process all over again. We look ahead, we check out what we're sitting on. Depending on what we're sitting on, we'll assume that we are about to parse something else. So it gets more and more and more specific until we're literally yanking values right out of the text, applying them to our own data structures, and then sending them off into our builder interfaces.
Okay.
So our parser tests are interesting because it allows us to match or specify what methods on our builders need to be invoked given a certain or a particular type string of text in our language. So this is the text that we're giving, and we want to expect these actions to be performed. When we hit rig.run, then it goes out and actually tells the parser to compile that CSS and convert it into actions and use those actions to match against what we expected to happen versus what happened.
Okay.
And so with all these tests, I mean, we have tests for every single case that our parser can handle. And then we, of course, have this huge test right here with a combination of things that our parser can handle.
Right.
And yeah, that's about it. So.
Okay. So going from here now, because, we might have some people out there wondering, well, now that we've broken all of this up, we've seen how to put a parser together by hand. Now we're going to be moving into the world of Antler.
Yes. So, yeah, Antler is basically going to write all the code we just wrote.
But it helps having an understanding of what all was going on behind the scenes.
Oh, yeah, completely. A lot of things about Antler will only make sense if you have a background with lexing and parsing. I mean, obviously, Antler is a tool and an abstraction over parsing. But if you don't understand how Antler goes about parsing those things, you'll run into telling it to do impossible things and not understanding why those things are impossible. So the recursive descent parser and lexer are something that Antler itself is going to generate. Its generated parser and lexers are a bit more complex. For example, our lexer, if you remember, has a specific amount of look-ahead. The parser that Antler generates has an indefinite amount of look-ahead.
Gotcha.
So that's an example of some of the things that, Antler does all for you. Not only that, the error reporting of Antler, it'll automatically generate a lot of nice-looking exceptions instead of just going into a tailspin or dying immediately like what this parser does. Antler generates a lot of code that will attempt to recover as best as it can.
Okay.
And so there's a lot of nice features of that. But again, the background in hand-rolling parsers is very, very important. Even in cases where you might want to parse something that's too simple to bother with Antler, for example, it's always good to know how to do these things by hand.
All right, well, let's go ahead and wrap up this introduction to parsing, and with that, that'll conclude this sub-series in creating the CGS language, and we're ready to move over into the introduction to Antler. Thank you guys very much, and we'll see you in the next subset.